Very often plot of land is taxed according to the area. Sketch the plot described, then find its area. Okay, from a granite post, proceed. Okay, from a granite post, proceed east. So, where are we going to put our post?
I'll just put it right here.
Upper left corner?
Yeah.
Okay, here's my post. That's the granite post. It says proceed 195 east along Tasker Road. So I'm going 195 east. So that's 195 feet. Then along a bearing 32 southeast for 260 feet. All right, let me erase some of this because it's going to be too much. So here's where I'm stopping. Then a bearing of 35 degrees, or south 32 degrees east, sorry. So what I like to do is put in a little line. I'll do like a light gray line to see my XY axis. That's X, and that's Y. Whoops. Well, this is Y is, sorry, X is just straight there. So then I'm going to go south 32 east. South 32 east. So angle is 32 degrees for 260 feet. So even longer than that other road. Mm-hmm. So let's do it about like that. So that angle right there is 32 degrees. South 32 east. That's how you do that. Okay. For 260 feet. Then along a bearing of south 68 west. So again, I like to draw my little light line right there, a vertical and horizontal line right at that point. So there's my next point. And then from there I'm going south 68 west. Ooh, I'm going to run out of space for a long ways. Mm-hmm. So this would be 68 would be there, and that's good. My angle's going to be way off. I started. I basically don't have enough paper to do this, or I made the lines too long. Mm-hmm. So let me quickly edit that. So this is where it gets tricky because it's hard to know how far to draw this line. That's 68 degrees west, but 385. It's probably going to go past. It's probably going to go past the granite post, but it's kind of hard to tell until you actually do the problem. So I'm going to assume, because I try to draw it as close as possible, I'm going to assume that so that angle there is 68 degrees. And the question is, how far did that go? Because this was 385 feet. I'm thinking, just based upon my picture, that it probably is past this line right here. Uh-huh. So I'm going to assume that, but we'll find out when we do all of our calculations here in a second. And then finally, and it says, and finally along a line back to the granite post. So now we're going to go back to there, but it's hard to tell what exactly that is. So now let's take all of our values and let's figure out using law of cosines what we have here. So first of all, I know that this angle, I like to draw my angles in, that's why I drew all these lines here. This angle is the same as this angle. So that angle right there is 32, which means this angle here is 32, 90 minus 32, which is 58.
58.
So there's 58 degrees. If that's 68 degrees, then that angle is 90 minus 68, which is 22. Mm-hmm. So this whole angle here is 58 plus 22, which is 80. Mm-hmm. So that's an 80 degree angle. This angle here is 90 plus 32, so it's 122. Okay, and we can find, let's see, what other angles do we have? So what I will do now is I will cut this into a triangle. So I'm going to turn that into a triangle so that I can find so now I can use the law of cosines to find out what, let's call this x over here. Oops. I want to find this side length over here. And I can also find this angle down here, and then I could find that angle down there as well. But I can find x, that side length, because I know 80. Sine of 80 over x equals no, not sine of 80 over x. I'm going to have to use the law of cosines because I have, so law of cosines, use the law of cosines. That's what it says. So to find x, I take the square root of a squared, which we're calling 260 squared, plus 385 squared minus 2 times 260 times 385 times the cosine of 80. And I get x equals approximately 425.512. So that's x, and now I can find the angles by using the law of sines to find the angles. So I know that the sine of 80 over 425.5, I'll round it, equals, we'll call this angle over here, let's see, A. We'll call that angle A. We'll call this angle up here B. So that equals the sine of A over 260, which means A equals.
And they all add up to 180.
So that's what A is. A is 37, and then B, if you did the same thing, you'd get 63 degrees. And that all checks out. So that's those angles. This is 37. This is 63. So if that's 63, we know that whole angle over there was, what did we say, 122?
Yeah.
This whole angle up here is 122, so 122 minus 63.
So 59.
So that angle is 59 degrees. And we know x, we already found x, 425.5. 425.5 is here. And so let's see, do I have an angle, side, angle, side? So I have to use the law of cosines again to find, we'll call this y over here. Use the law of cosines again. I'm not going to show that, I'm just going to tell you the answer. So y equals 365.5, so that y 365.5. And so we have all of our sides, and now actually we've split it into two triangles, and the easiest way to find the area of this, as far as I know, is to find the area of the two separate triangles, and there's a couple formulas you can use for that. I choose the area equals 1/2 AB sine C. If you have a triangle with two sides and an included angle, that's the best formula to use. So come to think of it, I didn't even need to solve for y. So the area of that triangle on the right is 1/2 260 times 385 times the sine of 80. And the area of the second triangle, the one on the left, so we really still did need to find that angle. We kind of had to do that work still.
For the 59.
Yeah, we needed to find that 59 and the x. So the area of that one is 1/2 of 195 times 425.5 times the sine of 59. So area 1 plus area 2 equals 84,851.3 square feet. Now, I'm trusting that I punched everything in the calculator right, but that's, at least from my perspective, the way to do that problem.